Hello, welcome back. Hope yesterday's lesson went okay for you. So this is the second and last lesson of the week. Again, we are gearing up for our first major test, which will be the end of this week. But for today, we are still in the category of analytic geometry. And today we're specifically focusing on circles. So good to know some of the basics about circles. Specifically, if you are given the equation of a circle, you're going to have to be able to find the center, find the radius, and draw a graph. Now, if you can't draw circles, it's okay. I'm going to tell you exactly what's acceptable, so no worries. The second group of skills or goals you're going to have to get to is writing the equation of a circle when you're given various information. So if you're given the center and the radius, you should be able to come up with an equation. If you're given the center and then a point anywhere on the circle, you can find the equation. Or if you're given the endpoints of the diameter of a circle, then you can also come up with the equation. So let's start with the formula. The circle formula is right here. R squared equals x minus h squared plus y minus k squared. In this formula, R stands for radius. So if you're given R squared, if you square root that, that'll tell you the radius of the circle. And then the points hk, the coordinates hk, create a point, and that's the center of the circle. Notice the formula has minus h and minus k, but this is h without a minus sign, k without a minus sign. So in essence, you're going to take the opposite of these two numbers to get your center. Now, before I get into the actual examples, because that's really all we have left is examples, and you'll see how it's done. Hopefully you'll find it easy. I do want to talk about this equation for just a moment. So I'm going to try and draw a circle using, there we go. Okay, so at the center of this circle is a point. The coordinates of that point are hk. The distance from the center to anywhere on the edge, that's the radius. So that's a fairly standard circle drawing. You've seen it before in geometry. You're familiar with it. Does that look anything like a triangle? And you'd probably say no. Of course it doesn't. Does it look like the whole drawing a line segment? No, it looks like a circle. Duh. Well, I want to point something out about this formula. So if we take this formula, r squared, tell you what, I'm a little bit lost here. I'm just going to copy this, see if I can do this right. Duplicate and bring it down here. There we go. If I just change the variables, because remember, variables are just letters that represent numbers. In one formula, you want to call something A. In another formula, you want to call it W. It doesn't matter. It's just a letter. So you can change these letters to any letter you want. If I want to change this R into the letter D, I'm allowed to do that. X, I could call that X2. You can give subscripts. That's fine. H, you could call that X1. Y, if you wanted to, you could call that Y2. K, you could call that Y1. It is a Y coordinate after all. And then if you want to isolate D, you don't want that square there. You would simply, square root both sides. And the square and the square root will cancel each other out. And you get this. Wow, I'm doing everything wrong. Lucky for you guys, you get to see me screw up all day. All right, so anyway, what is that formula? That's for the distance of a line segment, which we covered yesterday. So the circle formula is also the formula, in a sense, for the distance or length of a line segment, distance between 2 points. But we already said that this formula is based off the Pythagorean theorem. C squared equals a squared plus b squared. So if you look at x minus h and say, well, that's just a, right? X minus h gives you some sort of an answer. Y minus k gives you a different answer. Call that b. So now what you have is the circle formula is the Pythagorean theorem that goes with what shape? A right triangle. So it turns out that the Pythagorean theorem, which goes with triangles, is also the formula that gives you the length of a line segment, which goes, with, line segments, what I said, which also creates the graph of a circle. So one formula that goes with 3 different geometric figures: a line segment, a circle, and a right triangle. So that is kind of weird and interesting to me. It's really nothing, you're not going to be tested on this or anything. I just throwing it out there is, like I said, interesting trivia. Okay, let's actually get into the lesson. As normal, I will do the evens. Your assignment will be just the odds. There isn't always work to show, but where there is, show your work. And don't forget, again, to write your grade on the paper or type it into the comments. Do that, please, on every assignment. Okay, so what do the directions say here? Identify the circle, excuse me, identify the center and the radius, then sketch the graph. So the center is a point, and it's the opposite of this number, the opposite of that number. +3, -2. The radius comes from here, but the radius is not 4. In order to know what the radius is, you have to square root that number. So the answer is 2. So find the center, find the radius, easy peasy, right there. Now to graph it, here's what I want you to do. 3, -2 is the center. You all should be able to plot a point, no problem. The radius is 2. You can go 2 units to the right, to the left, straight up, straight down. And that kind of tells you where the circle is. Now, do your best to connect this with curvy lines. All right, does that look like a circle? No, it's all jittery and wavy, and this sticks out too far, but I don't care. The center's in the right spot. Your circle isn't extra huge or extra small. I mean, it's right where it should be. I'm not going to worry about how perfectly round you made it. If you have an Apple stylus, you can mess with the thing that does the auto draw if you want to, and this is only if you have the stylus, really. I don't think you can do it freehand. But then you move this over and you try to make it oh geez, how do I do this? Like that. I mean, if you really want to try to get that specific with it, bless your heart. If you just want to roughly sketch it out, do what I originally told you. All right, let's check the answers. So number 2, I gotta scroll way down. Okay, this isn't a big assignment, but I spread it out, so there's a lot of room to write. But okay, 3, -2, radius 2, and then there's our drawing. Let's do number 4. So the center. What is the center of this circle? Think it to yourself real quick. Did you say +4, +1? Because you do the opposite of this, opposite of that. You are correct. What is the radius? Okay, if you said 9, you are not correct. It's the square root of 9, which is 3. Now plot it. 4, 1 is right here. If the radius is 3, that means I got to go 1, 2, 3 units this way. Oops. 1, 2, 3 units that way. 2, 3 up. 1, 2, 3 down. And try to connect those with curves. Not perfect, good enough. If you can do work like that, so be it. And these are the only ones you have to draw circles on. So 1 and 3, the only ones where you actually have to draw anything. All right, let me go down and check number 4. 4, 1, 3, and the circle. Go up and look at my circle. Is it in the right spot? Good enough. So that's what I'm kind of expecting from you on 1 and 3. Okay, now we actually have to do math and use the formula. Use the information provided to write the equation of the circle. So let me write the formula. R squared equals x minus h squared plus y minus k squared. So in this problem, the r is 5, so that's going to be 5 squared equals x minus -10 squared plus y minus -12 squared. Now when you minus a minus, it turns to plus. So like I said, it's going to be the opposite of this number. And then minus a minus turns to plus 12, which, as you can see, is the opposite of that number. And then what is 5 squared? 5 squared is 25. So this is the equation of that circle. And no need to draw a graph or sketch it on this one. Let's check number 6. And there it is. Okay, I wrote my 25 on this side, and I wrote the answer over here on this side, but it's the same thing. No big deal. Let's look at number 8. So r squared, so 4 squared, equals x minus 9 squared plus y minus 14 squared. 4 squared, 4 times 4 is 16. X minus 9, you can't really simplify that, and you cannot simplify y minus 14. So as you can see, this is the opposite of that. Minus 14, that's the opposite of that. So everything looks right. This should be the answer for number 8. Let's scroll down and look. And there it is, correct. Okay. The rest of the exercises involve more steps. I did include a circle on each one. You don't need to draw a circle on each one. I only did it because I think it might help the explanation. Or maybe I'm wrong. So you don't have to worry about this when you do your homework. So let me make that clear. All right, so in number 10, you're told what the center of the circle is. It's 15, negative 11. And you're told that the point 16, negative 8 is a point on the circle. Now the formula, r squared equals x minus h squared plus y minus k squared. It requires you to know the radius and the center. We know the center. So this part of the equation is going to be x minus 15 squared plus y minus negative 11, or plus 11 squared. But we don't know what r is. Remember, let me do something here. Okay. Remember, r, the radius, is the distance from one point in the center to one point on the circle. And we don't know what that is. They didn't tell us. So guess what we have to do? We have to calculate it. We have to do the distance formula to find the distance from the center to the edge. So that's x2 minus x1 squared plus y2 minus y1 squared. That's the square root of 1 squared plus, okay, minus is plus 3 squared. So that's the square root of 1 plus 9 square root of 10. So the distance, and you know what? I don't want to confuse people with letter D for distance and the word diameter. I could see how that would be really confusing. So I'm going to call that r anyway. So the radius of this circle is square root of 10. Okay, guys, my Notability app just kind of crashed. It won't respond anymore. I can still write on it, but I can't move it. So I got to do something real quick. I got to close it, open it. Nope, I actually have to shut it down. Oh no, Haskell was playing a game earlier. And then open it back up. Okay, now it's responding. Okay, so I know r is radical 10, square root of 10. And you might not like that radical. You might say, ooh, that's nasty. I don't want to have to deal with that. Well, that's okay. I'm moving this work aside. Because the formula isn't r, it's r squared. So I have to do radical 10 squared. The radical comes from the answer. The square is part of the formula. And what do square roots and squares do to each other? If you said cancel each other out, you are right. The square root of 10 squared is just 10. Bring down the rest of the answer. Minus 11, I'm going to go ahead and turn that to plus 11. And there it is. So let's see, I probably should not have circled that since that's not the final answer. 10 equals x minus 15 squared plus y plus 11 squared. Let me check number 10 and see if that's right. And there it is. So this problem had all of this as extra work that you didn't have to do on the others. Number 12 will be pretty much the same. So let me go through this. The center is 15, negative 3. 16, negative 5 is a point on the circle. We're going to need to calculate the radius. R squared equals x minus 16 squared plus y minus... Oops, I was about to do that wrong. I'm plugging this number in here and was about to write it there. H and K are the center. So let me go back and not screw this up. X minus 15 squared plus y minus negative 3 squared. And in a minute, we'll take the minus minus, turn it to a plus. Don't worry about that. But we don't know what r is yet. So r equals the square root of 16 minus 15 squared plus negative 5 minus 3 squared. 16 minus 15 is 1. Negative 5 minus 3 is negative 8. 1 squared is 1. Negative 8 squared is 64. So the radius is radical 65. Let me move this work over a little bit. So now that I know what the radius is, I can plug it in right there. The square root of 65 squared equals x minus 15 squared plus y. Okay, like I said a minute ago, minus minus turns to plus. And then finally, what we said a minute ago, what do a square and a square root do to each other? They cancel out. So I can write a final answer, 65 equals x minus 15 squared plus y plus 3 squared. And that is the equation of this circle if it were on an xy axis somewhere. Let's check number 12. There it is. Oh, whoa, what? So clearly I've messed up. I got the 15 and the 3, but do I have a 65 there? For crying out loud? Yes, I do. So this is where I would love to just, I know I see it. I see exactly what I did. This is where I would love to just stop taping and start over, but I'm not going to do it. I make mistakes in the classroom. I'm going to make mistakes on a video lesson. So here's the deal. Right here, the formula is y2 minus y1 squared. y2 was my negative 5, y1 is my negative 3. This should be minus negative 3 squared. And when you minus a minus, what happens? I've said it a few times now, it turns into plus. Negative 5 plus 3 is not negative 8, it's negative 2. Negative 2 squared is not 64, it's 4. And 1 plus 4 is not 65, it's 5. So the radius is square root of 5, or radical 5. Which means up here, this should have just been radical 5. The square root and the square cancel out, which leaves me with 5. So there it is. Now, do you make mistakes on homework? I'm not trying to rationalize this. I'm just making a point. I did all this work and I made a mistake. How did I fix it? Well, once I found the mistake, I just edited. I didn't like start over and redo the whole problem. So when you see me mention from time to time something like, when you do your work and you grade it, fix your mistakes, it can be like what I just did. It doesn't mean you have to erase everything and completely start over. So that's just a little tip. Just be efficient. Understanding your mistake is the main thing. So fixing it is just kind of a little side effect to understanding the mistake. All right, so there's that one. So 10 and 12, basically, exactly the same process. So year 9 and 11 will be very similar. Number 14, another chance for me to make mistakes. All right, so here's a circle, and these are endpoints of a diameter. So if you remember from geometry, a diameter is like a line that goes, a line that goes from one side of the circle to the other, and it passes through the center, right? So one of these points is 9, negative 16, and the other point is negative 1, -2. Clearly this is not drawn to scale. They're not in the right spots, but whatever. Now, in order to do what we want to do, r squared equals x minus h squared plus y minus k squared, we need a center, hk, hk, and we need a radius. We have to have those two things. In the previous problem, they told us the center, and we calculated the radius. And maybe you'll do it correctly instead of making a mistake like I did, but that's beside the point. In this problem, we're not given the center and we're not given the radius, but we're still expected to do the same thing. So here's how you do it. The center of the circle is the midpoint of this line segment. So we're going to do the midpoint formula from yesterday. Let's just focus for a moment on hk. To find hk, we need to add the x's, comma. So add the x's, divide by 2, and then add the y's, divide by 2. That gives us 8 over 2, negative 14 over 2, 4, negative 7. So the center of this circle, instead of calling it hk now, I know that it is 4, negative 7. So this is a process we went over yesterday, the midpoint formula. So instead of saying I don't know my center, I do know the center. Now we need to find the radius. We can find this radius by going from the center to that point, or you can find this radius, center to that point. The calculations will look different, but they'll work out to be the same answer. It doesn't matter which one you want to find. I'm going to find this one simply because they're smaller numbers. Let's work with smaller numbers. So radius equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, in case you could not follow along with what I did, you got a little lost, I'm going to try to color code it. All right, so in orange, x2, x1 right here, and then let's do blue, y2, y1 right there, and then the formula, has that squared. So I'm doing the distance formula just like I did right here, and just like I did right here. It's the extra little work. So let's do this, and maybe I'll do it correctly this time. -1 minus 4 is -5. -2 minus -7 is actually plus +7. That's 5. -5 squared is 25. +5 squared is 25. Square root of 50. You cannot square root 50. We'll just leave the answer like that. Now there is a possibility of simplifying it, but we really don't need to do that because we are about to square it again anyway. So let me tell you what. I'm going to copy this, duplicate, and bring it down here just for reference. So what do I have? Radical 50 squared equals x minus 4 squared plus y minus -7 squared. So this becomes 50. Remember, the radical and the square cancel each other out. X minus 4, you can't simplify that. Oops, that was dumb. Plus y minus minus, you can change that to plus 7 squared. And boy, that better be my answer. If I made a mistake and have to come up here and redo this, that's going to be awful. Number 14. -4 plus 9, 74. You gotta be kidding me. Everything is wrong. What? 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 Number 14. Did I check the wrong one? What? Oh my word. How can everything be wrong? All right, you may write something mean about Haskell in the comments. You have free reign. Just keep it school appropriate. No swear words. No, nothing like that. I got to double check all of my steps now. So apparently I did this wrong. Oh, stupid. So dumb. I bet some of you saw this a while ago and you've been screaming at your iPad. What's negative 16 minus 2? I'll give you a hint. It's not negative 14. Negative 16 minus 2 is negative 18. Jeez Louise. Negative 18 divided by 2 is negative 9. Which means that this right here was supposed to have been a 9. And then negative 2 plus 9 is not 5, it is 7. Which means this 7 squared is 49. 49 plus 25 is, you guessed it, 74. So now I got to change this 50 to a 74. And then this negative 7 here, again, oops, I got to change it there. Oh, no. Sorry. It's a positive 9. So that's supposed to be a 9. And that is supposed to be a 9. Holy crap. So one little mistake in literally the second step of the process, and that screwed everything up. Well, they say learn from your mistakes. I want you to learn from my mistake. Yeah, that's how I'm going to justify this, rationalize it. You're learning from my mistakes. Congratulations. Quality education. Number 16 is the same. Look, if you got it, if you're good to go, stop the video now and get to work. Number 13 and 15 are going to be just like 14. If my mistake here threw you off and you're just confused, start fresh with me on number 16. I'll go through the whole process. I'm even going to cheat and look at the answer before I start, so hopefully I know what I'm shooting for here. So I'll just sort of put that in my short-term memory as I go through the process here. So get to work if you need to. Follow along if you want to. So here, the endpoints of this circle, negative 4, 14, negative 8, 18. We need to find, wow, that's awful, but we need to find the midpoint, and we need to find the radius. That's our goal. So the midpoint, which I'm going to call HK, because that stands for center HK, is going to be negative 4 plus negative 8 over 2, 14 plus 18 over 2. That's negative 12 over 2 and 32 over 2, which gives me negative 6 and 16. So the center should be negative 6, 16. Again, I'm going to scroll down to number 16 to make sure I am on the right track. I have positive 6, negative 16. Remember, they're supposed to be the opposites of those numbers. So I am doing, there we are. Well, I've got that part so far. Now we need to find the radius. I like smaller numbers, so I'm going to find this radius. You do have your choice. R equals the square root of negative 6 minus 4 squared. So I'm doing x2 minus x1 plus 16 minus 14 squared. So that's y2 minus y1. Negative 6 minus 4 is negative 10 squared. 16 minus 14 is 2 squared. Negative 10 squared is 100. 2 squared is 4. So I get square root of 104. That does not look right. Let me go down to number 16. Yeah. Something is gone awry. I'm glad I'm checking it. So let me back the truck up. Oh, stupid. I see what it is. Jeez, oh Pete's. This is supposed to be negative 6 minus negative 4. Negative 6 minus negative 4. Wow, you are getting a horrible education today. Minus minus turns to plus. Negative 6 plus 4 is negative 2. Negative 2 squared is 4. 4 plus 4 is 8. There we go. So now our circle formula, I'll just rewrite it, r squared equals x minus h squared, y minus k squared. So radical 8 squared equals x minus negative 6 squared plus y minus 16 squared. Square root, square cancel out. Minus minus turns to plus 6. And there is the equation. So I guess a tip, if you're still hanging with me, maybe on this worksheet, look at the answers before you start the problems, just to give yourself a little guidance. So that way you don't get carried away on one mistake and throw yourself off. And that will probably, you know, when you make one mistake in the second step like I did up here and it throws everything off, not only is it a mistake, but it can work on your attitude. It can sort of demoralize you and make you just want to quit. So if you kind of know the answers before you start, it can help you get through the process a little better. All right, I'm going to go ahead and stop here. Contact me through email or comments if you have questions. Good luck, and I'll talk to you again.